Find the indicated real nth root or roots of A. Part A, n equals 3, A equals negative 64. Because the index n equals 3 is odd, negative 64 has one real cube root. Notice that the quantity negative 4 to the third power equals negative 64. So the cube root of negative 64 is the cube root of negative 64, which equals negative 4, or the quantity negative 64 to the 1/3 power, which equals negative 4. Part B, n equals 2, A equals 81. Because the index n equals 2 is even and 2 is greater than 0, 81 has two real square roots. Notice that 9 squared equals 81 and the quantity negative 9 squared equals 81. So the square roots of 81 are plus or minus the square root of 81, which equals plus or minus 9, or plus or minus 81 to the 1/2 power, which equals plus or minus 9. Evaluate each expression. Part A, the fourth root of 81. Notice that 81 can be written as 3 times 3 times 3 times 3. So the fourth root of 81 equals the fourth root of the quantity 3 times 3 times 3 times 3, which simplifies to 3. Part B, negative the fourth root of 81. Notice that 81 can be written as 3 times 3 times 3 times 3. So negative the fourth root of 81 equals negative the fourth root of the quantity 3 times 3 times 3 times 3. The fourth root of the quantity 3 times 3 times 3 times 3 equals 3. So negative the fourth root of 81 equals negative 3. Part C, 25 to the 1/2 power. Notice that 25 to the 1/2 power can be rewritten as the square root of 25. Because 25 equals 5 times 5, the expression simplifies to the square root of the quantity 5 times 5, which equals 5. Part D, the quantity negative 25 to the 1/2 power. The quantity negative 25 to the 1/2 power is not a real number because there is no real number that can be multiplied by itself 2 times to produce negative 25. Evaluate 2. Part A. Evaluate 243 to the 2/5 power. Notice that 243 to the 2/5 power can be rewritten as 243 to the 1/5 power to the second power. Also notice that 243 equals 3 times 3 times 3 times 3 times 3. So 243 to the 1/5 power equals the quantity 3 times 3 times 3 times 3 times 3 to the 1/5 power, or 3. Because 243 to the 1/5 power equals 3, 243 to the 2/5 power equals 3 to the second power, or 9. so 243 to the 2/5 power equals 9. Part B. Evaluate 16 to the 3/2 power. Notice that 16 to the 3/2 power can be rewritten as 16 to the 1/2 power to the 3rd power. Also notice that 16 equals 4 times 4. So 16 to the 1/2 power equals the quantity 4 times 4 to the 1/2 power, or 4. Because 16 to the 1/2 power equals 4, 16 to the 3/2 power equals 4 to the 3rd power, or 64. So 16 to the 3/2 power equals 64. The radius r of a sphere is given by the equation r equals the quantity 3v divided by 4 pi to the 1/3 power, where v is the volume of the sphere. Find the radius of the basketball to the nearest inch. Use 3 14/100 for pi. First write the equation. R equals the quantity 3v divided by 4 pi to the 1/3 power. Because the volume of the basketball is 463 cubic inches, substitute 463 for v and 3 14/100 for pi to get r equals the quantity 3 times 463 divided by the quantity 4 times 3 14/100 to the 1/3 power, which simplifies to the quantity 1389 divided by 12 56/100 to the 1/3 power, or approximately 5. So the radius of the basketball is about 5 inches. To calculate the annual inflation rate R in decimal form of an item that increases in value from P to F over a period of n years, you can use the equation R equals the quantity F divided by P to the 1 divided by nth power minus 1. Find the annual inflation rate to the nearest 0.1% of a house that increases in value from $300,000 to $360,000 over a period of 8 years. First write the equation. R equals the quantity F divided by P to the 1 divided by nth power minus 1. Because the house increases in value from $300,000 to $360,000 over a period of 8 years, F equals 360,000, P equals 300,000, and n equals 8. Substituting these values into the equation gives R equals the quantity 360,000 divided by 300,000 to the 1/8 power minus 1, which simplifies to 1 2/10 to the 1/8 power minus 1, or approximately 231 10,000ths. So the annual inflation rate is about 2 3/10%.